Sorry, my background might be echoing. So SCSSN is for full Special and Data Science Society of Nigeria, which has been in existence for over 5 years and still counting. And if for those who have stuck with us, who have been on this journey with us for the past 5 years, I know that you would notice the significant growth and change that we've had, and we keep growing stronger. So over the last year, we have developed and grown into having and issuing certificates to further boost our members and give them something to make us even more credible than we were before. So we have 4 categories of these membership certificates. We have the one for graduates, we have the one for professionals in special and data science, we have the one for associates, which is for individuals and persons who have interest in special and data science, but yet they have no knowledge of it, but yet with their interests, the associate membership gives them the avenue to be part of the society. And then we have the one for corporates, which is for firms who would like to be our partners in what we are hoping to achieve across Nigeria, Africa, and the worldwide. So that being said, today on this call, we have our facilitator, who is in the person of Mr. Emmanuel. Mr. Emmanuel is a professional member of SDSSN, and I'm sure everyone here who has subscribed to our membership program have a lot of stories to tell, and you would see that by the time I am done telling you a little about Mr. Emmanuel, you would know that the persons who have subscribed to our certificates are not just little people. We are gradually growing, and we are getting there. So for you to be a part of this SDSSN certificates program, you could check our website, www.sdssn.org. I would drop the link on the chat in a bit, but while we wait for that, let me tell you about Mr. Emmanuel. He's a professional member of SDSSN, like I said, and also he is the Chief Executive Officer, CEO of ArcGIS Geospatial Services. And the ArcGIS Geospatial Services happen to be one of our very own partners who have keyed into the goal and the mission and vision of SDSSN together to achieve the goal, the common goal. So ArcGIS Geospatial is into GIS, is into remote sensing, is into training and a lot of other spatial and data science uses and applications to providing solutions to public and private sectors. So while I would let Mr. Emmanuel to tell us a little about himself, I'm sure we are eager to get to know what he has to say and to teach us about the topic for today. I hope we all have our tools and gadgets ready to learn and practice along. Although the link for the video for this call will be shared later, and the materials also will be shared for those who would like to have it and make practice after the call. So thank you all for listening. I would allow Mr. Emmanuel to take it from here. Hello, Mr. Emmanuel.
Yes, I can hear you. Can you hear me, please?
Yes, I can hear you. Go ahead.
Okay. Right. Thanks, Rikia, for that introduction. I really appreciate that. And also, I want to start by appreciating the Spatial and Data Science Society of Nigeria. I really appreciate this opportunity for this kind of trainings. I have attended the ones in the past. And the last one by Jovola on pixels, and this has really been inspiring. And we keep learning every day. So I appreciate all of this, and today I'll be talking to us about uh, 3D terrain mapping. Just imagine being able to see your mountains rise, valley deep, and landscape transforms right before your eyes. Now, this is the power of 3D terrain mapping. And today, I will show you how to create it. 3D is this part of GIS that we keep learning every day. You get to see how it is very much relevant in our everyday life and in different sectors. I also like to mention to you that I'm also a member of uh, the Institute of Certified Geographers of Nigeria, and I have my BSc from the University of Port Harcourt, my BSc in Geography and Environmental Management. So it's something I've been studying. I just had to mention this line first so that you understand how we've been into landforms and etc. Things that has to do with the terrain topography and topology of the world and the earth feature and how it is seen. So it's something that has really interested us, and I have seen its applicability on our everyday lives. So this is what we'll be working on today. I will also be showing us the practical part of it. We'll do a little of the theory of it, and then we get to see what we have achieved at the end of the day. So I think if you can hear me, I would like to share my screen now. Please, Ms. Rega, can I go ahead?
Yes, you can.
Okay. I think you should enable me from your own end.
Yeah, you should be
Okay.
able to share it now, sir.
Okay. Thank you very much. One sec. Okay. Okay. I hope you can all see my screen, and I hope you can hear me. If someone can hear me, just say hi or respond,
Yeah,
please.
yeah, we can hear you clearly, sir. We can see the screen.
Okay. All right. Thank you very much. I appreciate that. So again, this is the topic for today. 3D terrain mapping using ArcGIS Pro. It's one of the softwares owned by Esri, Environmental System Research Institute. They are the global owners of this um, ArcGIS softwares. So the objectives of today is, let's see in this webinar, how we'll gain insights into the fundamental differences between 2D and 3D GIS, along with the practical skills to create a true 3D terrain model using ArcGIS Pro. And of course, also expect that this section aims to build the confidence in using advanced geospatial tools like what you just mentioned, the ArcGIS Pro, for visualizing spatial data effectively. And this part I just highlighted here is just basically on our practical session. We'll be doing that. Although I included, the steps so that when the slides are shared at the end of the day, can be able to understand and, it will be like a guideline, yeah, a guideline for whatever we're doing, and we can also be able to replicate whatever we have achieved at the end of the day. So this topic you're seeing here, I like what you saw earlier on, 3D terrain mapping. So I had to highlight this 3D GIS because I attended a webinar um, years back, and I understood something there. It was about 3D GIS, but that day I learned how the little similarities, although there's difference between what we call 3D GIS and 3D terrain mapping. So this is very important. That was why I had to highlight that 3D GIS and start with that. So, firstly, again, I will rephrase what I said earlier on. I said, imagine being able to see your mountains, the hills, the valleys around you, and even the landscape, how they transform right before your eyes. And imagine the power of 3D terrain mapping, what we'll be able to learn today. 3D GIS simply means using geographic information system to view, analyze the Earth's surface in 3 dimensions. That is the length, the width, and the height. So instead of looking at a flat map, the 3D allows you to see the hills and the valleys, the building heights, if you're into valuation, inspections, and so on, the slope and the elevation. You see the undulating, surface of the earth, and so on, etc. So, in simple terms, the 3D GIS helps us to see and study the real world more realistically, making it easier to plan, analyze, and make better decisions. Here I highlighted little differences here so that we can understand as we further we can be able to get them clearly. I said 3D GIS provides the height and perspective for realism. The 2D map is the flat representation, the basic map you prepare, the map of Nigeria, Africa, map of Zimbabwe, and so on. The 3D scenes is talking about the terrain plus the height and then the perspective. Okay, and yes, they are used in planning, analysis, even storytelling, and of course, majorly is to aid us in better decision making. So today, just like the topic you saw there, the 3D terrain mapping, this is what we'll talk about now. So when I'm done with this 3D GIS, 3D terrain mapping, we can be able to see the similarities and then the little difference. Firstly, we'll understand that terrain refers to the physical features, shape, and topography of a tract of land. Now, it is defined by its horizontal and vertical dimensions, typically described through elevation, the slope, and orientation. Now, 3D terrain mapping shows the Earth's surface in these same 3 dimensions I mentioned, the length, width, and height. And it allows us to see the hills, the valley slope, and the elevation differences, their realistic landforms. Now, if you understand clearly there, I'm just mentioning the hills, mountains, slope, and so on. Now, that is the terrain. Okay, that is the terrain. And in 2D GIS, we only see the length and the width, but the real world has height. And that is what has introduced the 3D part of it. So the 3D GIS allows us to represent these terrain buildings, landscape as they actually exist, making us to analyze and communicate and be able to have communication power, much powerful. And using this tool, GIX, the ArcGIS Pro, we can be able to create, analyze the real 3D landscapes. So here on your screen, you could see some pictorial views about 3D GIS, the 2D GIS, and then the 3D terrain mapping. So I know some of us who are part of this session, I know it's comprised of both the GIS experts and those that have little or no knowledge of GIS. So that was why I had to, highlight or break those things so that we can be able to get it clearly. So in case we hear this and then understand, or when we go into the advanced aspect of 3D, we can know, oh, this is the 3D GIS and this is our 3D terrain mapping. But majorly, or basically, this is a thing we have to understand when it comes to 3D GIS. It's talking about you seeing the world, the real world, the map, the 2D flat map you see, the map of Nigeria, or you've done map of or land use land cover map of a place, or you have done whatever kind of spatial analysis in different forms. Getting to see this now, feel it, seeing it look like the real world that the real things you see on a daily life. That is what we talk about the 3D. So now feeling it in the length, width, and height perspectives. So I said the simple difference is here for 3D terrain mapping is about the land surface, okay? And 3D GIS now includes terrain and everything built on or under it with analysis tools. I mentioned something earlier on. I said for 3D terrain, you need to understand it's talking about the land surface. And then when we will now involve, when we say 3D GIS, that means it's encompasses of both the 3D terrain. Now you're trying to advance your project. Maybe you're working on projects, you're talking about erosion or trying to talk about flood risk zones and so on and so forth, or there's a disaster outbreak and so on. Now you get into source for other data to advance this particular project or your research on it. Just like you can see on the screen, you can see my mouse move there. You can see the 3D GIS. There's a pictorial view of it. You can see buildings that are highlighted. Probably they are doing an evaluation on this place, or they're trying to map out a particular location here of whatever it is needed for. And then you can now see the 3D terrain map talks about the hills. So if you look at your screen there, you can see clearly this is AMAC. Anyways, when we go to the presentation, you can get a clearer view of that. And you can see your Aso Rock and Aso radio station that is in Abuja and so on. So it's just talking about these earth features, mountains and so on. But when we talk about 3D GIS, we're talking about advancing your analysis, bringing in or yeah, rather, on advancing the tools you're using to project your 3D mapping. So at least I'll be able to, explain the basic difference between these two things. As like I said, they are similar because 3D terrain mapping, it's under 3D GIS. But at least so when we hear this outside, we can be able to say, oh, this is what we call 3D terrain mapping, and this is what we call 3D GIS. And then your 2D GIS is just the flat map, looking at the world on a flat surface. Further on, I had to just bring a view of what map looks like and what our scene looks like in ArcGIS Pro. So it's the scene, that is where you work on 3D, and the map is the basic map you produce every day. Just like the previous map you saw, your 2D GIS, that's a map of AMAC, Abuja Municipal Area Council in FCT. Okay, and then I said in continuation here, in ArcGIS Pro, a 3D map is called a scene. And a map is really 2D, just like I've mentioned earlier on. So for city or local projects like AMAC, we can, use a local scene which allows us to which allows detailed terrain visualization. And also in AMAC, as Abuja Municipal Area Council, we have 3D terrain mapping. It's very important because the area is growing fast and has many hills, slopes, and flood-prone areas. It helps planners to see the land clearly, choose safe place to build, design proper drainage, and even reduce flooding and erosion problems. So, of course, like Abuja now, I know it was planned and it was built from the scratch, but I believe that whoever or the people who build this thing, if they have embraced this thing, definitely it should have been a better planning, because now we're talking about real the real transports and issues and so on, and whatever it is now that needed to have been done. I believe that getting to view or see the world in the 3D perspective could have been a better idea or way out. So I said, even though AMAC faces challenges like rapid growth, poor drainage, and heavy rainfall, 3D terrain mapping helps leaders make better decisions and smarter development. So here is an important aspect of this, because I know some of us here will be like, okay, what is it talking about? Is it just the 3D and so on? So how about the relevance? How is this applicable? And where can I attain or get this knowledge? And where can I apply it as well? So these are basic problems you can find and more. And there on the right side of your screen, you can see the solutions there. So basic problems like rapid urban growth. Okay, we use ArcGIS Pro to analyze terrain before building roads and houses. So real estate firms, the construction sectors, and so on. This is something they have to embrace. They need the knowledge of this as well, and of course, most importantly, they need the knowledge of ArcGIS Pro or your GIS tools to know how to plot this kind of 3D maps. Flood risks and climate change. So we can do model elevation and identify the flood-prone areas. So getting to see the undulating surface of the location or Abuja and so many other places, we can be able to model elevation and identify flood-prone areas, and then save the issues of flood risks and of course climate change. Now, when it comes to infrastructure development, we can be able to perform slope and site suitability analysis. So for the construction sector, again, those building, you're trying to build, for instance, trying to build a railway from Lagos to Abuja or to Kaduna and Kano and so on. With the use of this 3D, we can be able to see these places properly, get to feel them, or get a better visualization of these kind of places, and then know the best way to plot our routes. Okay. Then when it comes to problems like environmental protection, we can be able to monitor erosion and water washed areas in 3D. And most importantly, the reason why we study this is for us to be able to make better decisions. So with the idea of 3D or getting knowledge of 3D, we can be able to create realistic 3D maps for clear uh, decision making and presentations. Okay. So before we go to this important aspect of 3D mapping, it's called digital elevation model, the DEM. Okay. I would want us to get some things clear here so that for some of us who are new here and don't understand some basic words I'll be using here, I would want us to understand what they are. And these are things like raster and data. So in GIS, you're trying to plot whatever map, you're trying to do whatever analysis, you're trying to create your 3D and so on and so forth. You use your data to plot all of this. You include them on the software and you're able to project and able to produce whatever kind of map you're working on. But these data have their different types, like the raster data and the vector data. So um, I want us to, I didn't include it here on the session so that because it was supposed to just be a practical one, but it's still important to understand that when it comes to GIS, there are basically two kinds of data. We have one, the vector data, and vector data represents geographic features such as points, lines, and polygons. Okay, and then it's used for discrete features, things with clear boundaries. And the types of these vector data are, like I mentioned, I said points. You can use as a single location, like you're trying to do a research on borehole, schools, and so on, ATMs. And when it comes to lines, like I mentioned earlier on, it's part of the features when it comes to vector data. We talk about road, we talk about river, we talk about pipelines. So you're trying to create a point of connectivity within these locations. And then when you talk about polygons, then we talk about shapefiles. They are the ones used to define the boundaries of a place, the boundary of Paris, the boundary of Uyo, the boundary of Ama, the boundary of whatever location. Okay, and then raster data is a second type of data, and raster data represents geographic information as a grid in tiny squares, like they are called pixels. I think in the last session, Mr. Jebola worked. He did justice to pixels. So he's talking about raster data, and this is another kind of data you use when you come to mapping. Okay, example of this kind of raster data are satellite imageries. Are you able to visualize whatever we're talking about, the earth picture that we're talking about here? Talk about elevation maps and even this DEM data that we're talking about today. So I had to divert a little because I wanted us to understand these kind of data. Okay, so the DEM again, which we're talking about now, I just wanted to have a little understanding of this kind of data so that when I'm explaining, it will be clear for us to understand. I said a digital elevation model, DEM, is a raster data set that shows the height of the land surface. So in simple term, DEM helps us to understand the shape of the land, meaning the high, the low, the flat or steep areas. So why is this DEM I'm talking about? Why is it important? It enables 3D terrain visualization. So the hills, the valleys, and the slopes talking about visualizing them. It is the DM that helps us to understand is the digital elevation model, just like elevation. So you're able to feel the hills, the slope. You want to know how undulating, how steepy, how slopy the area is. It is the DM. It also helps us to calculate the slope aspect and the hill shield. And of course, it supports the flood and drainage analysis, like I mentioned. You're trying to advance your mapping, your 3D mapping. You can be able to support this using the DM. Okay, and another one again here, why it's important is that it assists in urban planning and infrastructure development. So DM has been cited as an important data set, raster data sets that will help us to understand the height of the land surface. Okay, and why it matters is because it makes map more realistic and easier to understand. Also, it supports better planning and decision making. And also, you need to understand that it's essential for disaster management. We'll be mentioning flood, erosion, landslides, etc. And it works with modern GIS tools like the ArcGIS Pro that we'll be using today during our training session for 3D mapping and analysis. And most importantly, why it's important for this training is that DEM is the foundation of 3D terrain mapping. So you need to know that without DEM, there is no terrain surface. Without it, there is no elevation data. Without it, there is no slope analysis. And without it, there is no true 3D visualization. So everything in 3D is made up using DEM, the digital elevation model. Next here on our slide, um, please, I hope I'm not moving too fast because it sounds like I'm trying to hit the time. Please, if I'm moving too fast, someone can let me know. Can
No,
I get a
we're
response,
good.
please?
We're good. Go ahead.
Okay, thank you very much. Okay, for the sources of the data we'll be using for this training session, the practical aspects, I just want us to highlight them here because I need to show us that we'll be using the administrative boundary, so I'll be able to map out the boundaries and the location of the place or the defined area of focal study area. So administrative boundaries is what we're using here, and this is just looking at them. It's just talking about the sources where you can find them. You can get them, of course, for Nigeria. You can get it from Office of Supervision General Federation. You can also get it from Grade 3 Nigeria or GADM, GADM. You can also find your administrative boundary from the Humanitarian Data Exchange. These are sites you can go download them. Even DivaGI, there are so many of them. So when it comes to mapping and so on, you have your internet, you can easily source out the places you can be able to find these data sets. Another one again, well, which you just finished talking about now is the digital elevation model. So it provides elevation values for terrain modeling. That is what it does. And the place we can find this kind of, we can source this kind of data, the sites are our US Geological Survey, and that is a USGS. USGS Earth Explorer. You can get the DM there. You can be able to download them. So when we get to our practical session, I will show us how we can download this. And you need to know that it is a raster. It's a raster data. And the satellite imagery, like I said, is optional because we're talking about the terrain. But these are data sets and where we can be able to find them. So for the satellite imagery, you can easily even add it from your ArcGIS Pro. ArcGIS Pro is an advanced GIS tool, like I mentioned earlier on, owned by Esri, and they have been able to make available so many plugins where we can easily download or add some of these data sets. Okay, one of them is the S3 Living Atlas. You can find it there on the software when we get to that place. And again, even the USGS has that, or your Google Earth. Okay, and next we'll have the land use land cover. Uh, that is when we want to advance on our spatial analysis. We want to do 3D. If you're trying to advance this, you can bring in your land use land cover data sets, and you can find this from even your USGS. You can get that the ESA world cover. You can be able to download it from that site. and then you're trying to work on your watershed boundaries. You can get that from your hydroshed and USGS. And this is another kind of shapefile you can be able to use to work, or vector data you can be able to use to work during 3D mapping. Okay, and next here on the slide, I just mentioned some recommended free data resources. Okay, I already mentioned the USGS, that's the United US Geological Survey Explorer. So I mentioned there that you can get your DM there. I mentioned NASA. You can get your DM as well there for our land use, land cover, and other things. This is just basically some recommended free data resources. So because some of them you have to subscribe, you have to log in, create an account, to get them accessible. Okay, so we have, I just highlighted so far the basic things we need to know before we dive in deep into the practical session. This is where we'll be using the ArcGIS Pro to create the 3D terrain map. Okay, and before I further go on here, because I'll just run through this so I can move quickly into the practical session. I don't know if anyone has, let's say, if I can pick one or two questions there so that we can do with what we have today. Today is basically a practical session. Okay, so but if anyone has any question, I would like to attend to that.
I think the questions would come in after the practical session. I'm sure
Okay.
everybody is eager to see how flat terrains gets transformed into realistic 3D.
Okay. All right. Thank you very much. So again here is just I'll just show us, these are just basic steps. I included this part here because this is just how basically the way we can be able to create or transform our 2D maps into the 3D map. So I just included it on the slide so that when sharing, people can be able to have it as a guideline, like I mentioned earlier on. So I don't know if it's need to see, but anyways, let us go straight to the practical session using the software ArcGIS Pro. Okay, so you give me a little second so that I can change. Okay, this is the ArcGIS Pro software. Okay, and first things first, I would advise us on something. It's important while learning. If you're trying to do a good job, part of the things I was taught and it has helped me today is, you do a clean one. So it's important we create folders, you know, before um, proceeding in your map. Now, for this session, there is something I did. I had to create a folder. I don't need to start showing us how to create folder and so on, but I created folders where um, I could get easily access the data I have already downloaded from these sites. I mentioned these places. I mentioned the sources and I mentioned websites where we can easily download this data. So I had already stored them in there. Okay, but I think I will have to show us um, because part of what is in this session, I have to show us how we can easily download the okay. Sorry, one second. Okay. Yes. So it's part of what's this session. I just want to just take us a little prep on how we can easily download some of these data sets because we're mentioning the DEM and so on. So it's important for us to understand. I mentioned earlier on that we'll be downloading this our data set from the US Geologic Survey. So you can just type in USGS. Okay, and all right. So if you're still seeing my screen, this is the USGS platform. And for you to access the digital elevation model, we have to log in on their website. So you have to create an account or log in if you have to create an account if you don't have a username or haven't registered on their site. So just putting in mind, or just have it in mind, you have to create your own account. All right. Let's see. Okay, so we have here our USGS platform, the Earth Explorer. So for us to download the digital elevation model data set for AMAC, because for this practical session, I used AMAC, that's Abuja Municipal Area Council, as our focal point, or rather the study area. So for you to do that, you have to click on World Features, okay, and then here we have uh, feature name. How you can type in Abuja Municipal. Okay, and tap enter. All right. So two things is either you navigate to that place, or you can zoom out and okay, you can either zoom out and navigate to Africa. I think this is the data is a little bit poor at the moment. Okay, either you zoom out or you click, you type the AMAC and then you click on what you have typed, the results you found, to be able to take us to this location. All right. So here we have AMAC in Abuja. This is where it's located. Again, I just want us to make sure we're following. I said you have to type the future. When you type AMAC, Abuja Municipal Area Council, Abuja Municipal Area Council, and then you tap on enter. Then we're able to zoom to this place. So it's either you have idea already of where the AMAC is located, and then the next thing you have to do is uh, to get the DEM of that particular location or area. And for us to define this area, okay, you can zoom in, and then next you clip to get the coordinates of this area. All right. So if AMAC is located here, what I just did now is by clipping this area so that I can get the DM of this location. Okay. So I will also say it's safer to just get the whole of Abuja's DEM. At least you know that it covers that particular area. Since we are the Earth Explorer here wasn't able to show us the particular shapefile or boundary of AMAC in this location, but it's just better you do you attend this using this particular step. All right. So I guess by doing this, we've been able to cover the whole of AMAC boundary, the Abuja Municipal Area Council boundary. Okay. And then next you click on data set. So this will take us to where we'll find our digital elevation. Okay. So you scroll to that point and then you look for SRTM. It's your shuttle radar topography mission. And then you click on SRTM 1 arc second blue. Okay. And then search for results. Okay. Sorry about that. I think that was part of network issues. All right. So basically, we'll have four different data sets here. We have uh, this entity ID. So it's basically for you to just download this data set. And then remember, I mentioned earlier on, you should just create a folder where you can easily store this where you can easily store these data sets. So when you click on any of them, I would advise you download four of them so that you can be able to access them. So that's it basically anyways. So by following this step, you'll be able to download our AMA. So now I want us to understand that when you're downloading this data set, you look for a GeoTIFF, the GeoTIFF files. because I don't think I highlighted that. The GeoTIFF file is what you'll be downloading. Okay, so when you download each of the, you can see the 24.76 MIB. That is what you'll be downloading when you're downloading the GeoTIFF files. Okay, and then when you have downloaded them all, you can be able to save it on the folder where you created. So here is my downloaded file, and I created a folder. I named it as last webinar, and then you can save it. So basically, I just had to follow this step because it's important for us to see at least how to download this digital elevation model datasets, and then we can now be able to plug it in on our ArcGIS Pro. Okay, so this is what you do or replicate for the remaining four of them. To save time, I will just take us straight to the software. Okay. All right, so all right, back to the software itself. I believe we can see my screen. I have just shown us how we can download the digital elevation model, though I had to just save time, so that we can do a work on what exactly has brought us here today. Okay, and that is transforming the 2D maps into 3D, or creating a 3D terrain maps. Okay, so to start with, you open a new map, and then you can name it. Let's name it our 3D terrain map. Okay, so remember, you click on map and then you name your project. So you have to just give a little time because of network. It's taking a little time. Okay. All right. All right. So the basic thing I just showed us again, the 3D map is something that is just very important. I just wanted us the digital elevation model data set was something important. Coming to the 3D is something that won't take us time at all. So first things, you click on your map and then you click on add. Okay. So when you click on add, you navigate to the folder you have saved these files. Okay, so the first thing we have to put in here is our admin 3. I mean 2. That is the our Abuja Municipal Area Council. So I just wanted to remember that we downloaded the Nigeria shapefile as part of the data we had to source to be able to produce this map. Okay, so
Hello, Mr. Emmanuel.
yes, please.
If you're still presenting, your screen is not visible to everybody.
Oh, sorry about that. Sorry, please, can we see our screen now?
Yes, it's visible now.
Okay, sorry about that. Okay, what I initially did was, okay, to save the time, what I initially did was just to open our ArcGIS Pro work page. I remember I showed that before I went to the digital elevation model data sourcing. And what I did here was basically adding the data we'll be using for this 3D. And I said that our study area is Abuja Municipal Area Council, AMAC. Okay, so the first thing I had to do here was to click on map and then add data. So when click on your add data, you can be able to navigate to where you have stored your downloaded data. And remember, I said we'll be using the Nigeria shapefile as part of the data sources that we're using here. Okay, and for us to get the AMAC is you can find that in admin 2 or just call it if you haven't already created your AMAC shapefile. But this is one way you can be able to do that. Anyways, so you right click. You right click on that to navigate to where you find your AMAC. Yeah, Abuja Municipal Area Council. Then, so you go to selection and make this layer from selected feature. Okay, then uncheck this. So here you can either hold and click to rename this, or right click, go to properties, and on general here you can be able to rename this as AMAC. Right, and then zoom to layer. So to do that, you right click again. So this won't be necessary anyway, so you remove it. So here we have our AMAC. Okay, and remember we're trying to show the feature located within this area. So we work on the symbology, and here we have AMAC. You can equally label it. Okay, so the next data sets, if you look on the slide, it's the DEM. Okay, so there was something I did before now. I mentioned again that I had to open a folder so that I can easily access these data sets. Okay, so all right, so this is the AMAC data set. So these were the 4 digital elevation model data we found before now that was supposed to download from the site. Okay, so it's either you, excuse me, add them, or you add them first and then you mosaic. Okay, all right, we'll give it a little time to load. Okay, so here we have our DM data. Okay, so we'll be working with, I also want us to understand, working with uh, the DEM, extracted DEM, because there's a reason why we had to plug in AMAC shapefile or band refresh so that we're able to extract the particular feature we'll be using to further on our 3D map. So for us to do this, we first need to merge all of these four data sets, these four raster data here, which is the digital elevation model data that we have downloaded as one. That is how it works here on GIS. And for us to do that, you can click on analysis.
Hello, Mr. Emmanuel.
Yes, please.
Your screen is no longer visible, and I think we have exhausted our time for the day. This is an hour already. I know maybe you didn't take note of that.
Okay, but okay, maybe we should just okay. What I will do now is just to fake the mosaic because I actually mosaic the data, but I was just trying to show the steps what we'll have to get this. But don't worry, I'll try and see how I can save the time, please.
Okay, it's just so we don't get logged off because the time was set for scheduled for one hour.
Okay, so I think you should please notify me once you observe this because I don't know why I can't find it here, but I can see sharing screen here. So I think
Yeah,
you
it
should.
is now. Your screen is visible, so you could
Okay.
go ahead and maybe just let's do everything quick.
All right, thank you.
All
So
right.
sorry about that again. And I said again, the next thing we have to do here is to mosaic this data set. So I think I will have to save that time because our time is very fast spent here. Okay. Click on tools and then mosaic. So you click on mosaic to new raster. And this is how you can be able to add the data sets you're trying to mosaic. Okay, so we have to take them accordingly, just as seen here, 7, and then the last one. Then you choose your output location, and then when you choose your output location, you can be able to save your raster name. And then the next thing is the spatial reference. The spatial reference is AMAC because that is the area we're trying to see how we can, add in. Okay, and then for your bit bounds, you can use 8. 8 is fine. And then that is it basically if you're trying to mosaic. Okay. So but to save this time, because I know to run that, I think the system is going to take a little time to do that. But to save our time, I already have one that I have already mosaiced, and I will just add it within seconds here. Okay, so this is DM mosaic, and remove all of this. Okay, so following the same procedure I was talking about before now, this is the same way you can mosaic and get one of this in this pattern. All right, so after doing this, this is the very last thing you have to do before you can now switch to your 3D. Okay, and to do that, you click on View and then click on Convert to local scene. All right. So by so doing, we'll be able to say we have converted from our 2D view to the 3D view.
Yes, your screen has stopped working again.
Okay, thanks for notifying, please. How about it now? Is it showing, please? Please, can you see it from your end?
Yes, yes, yes. Thank you, sir.
So basically, we have just, yeah, thank you very much for that. So basically, we've just converted to our 3D. And here is another tool we found here. This is what we can use to navigate within a 3D. Okay, so firstly, there was something we were supposed to do, though we omitted it. But either ways, we can still work with this. But at least we can be able to find our AMAC, visible here. So the next step we'll have to do is to click and drag the DM mosaic. This is DM mosaic, digital vision data we mosaic, trying to get the boundaries of AMAC um, local government area. So you can drag it down to ground where we have elevation surface, and then uncheck the world elevation that was already existing there. Okay, so that we can have a focal point of where we are trying to visualize. Okay, and then this is your navigation tool. If you can see my screen, this is where we can now be able to tilt, rotate, and turn to different angles we're trying to view whatever of which it is. Okay, then most importantly, you have to drag AMAC to 3D layers, you know, to create. Looking at points we're working on. Okay, so here we have our location, and then you use this tool like to tilt and view in different ways or angles you're trying to view it from. Okay, so here we have the 3D view of our AMA. You can see the line, the black line, that's the black boundary showing AMA Municipal Area Council. And then we can have the 3D terrain view of this. So I know time is already fast spent. Okay, and you can actually further add your base map. You can use terrain as a base map to add, just to bring out, the surface and bed. So if I have to zoom in here, I know our internet is part of what is causing this slow movement on my screen here, but at least we can be able to view the rocks. This is the Aso rock, okay,
Your
and
screen is no longer
looking
displaying.
clearly. All right, I believe we can see my screen now. Actually, this is the last part of the phase when it comes to practical on the 3D terrain. Okay, please, Miss Idris, can you see my screen? Hello, Miss
Yes,
Idris, can you see my screen?
yes, I can
Okay,
see your screen.
okay. So sorry about the whole screen going off and on. I really understand the cause, but at least here we have uh, the view of our AMAC,
It has gone off
Abuja
again.
Municipal
Sorry
Area
about the
Council.
interruption. Sorry about the interruption. It has gone off again.
Okay. I honestly apologize for the screen going off and on. But anyways, this is what we have here. The view on our this is a 3D terrain view of this place. At least we can be able to see, the locations here. We can be able to see these hills and so on. I'm trying to zoom in, but I don't know. The network is not helping matters. So let me see if I can be able to add a base map here. And it's advisable use terrain and labels. This can help. Okay. Okay. Oh, I think the internet is the internet is not favoring me on my ends. But anyways, this basically is what well, at least we're able to see, getting to view the world, seeing it on its realistic form. Okay. Hopefully in the next section, or when next we'll have this kind of training sessions again, I'll be able to show us better on what we can do or achieve, to get to this point, and then how this can solve our problems. Now we can see our hills there, like I mentioned earlier on, the mountains and so on and so forth. So now think about the sectors I mentioned and think about how relevant this could be. For instance, the real estate sector, like I mentioned earlier on, think about how they can make use of this while building their houses or during planning, or people who built Abuja or how it was planted and built from the scratch and so on. Think about how they can embrace or seeing these features around these places. Where and where can we, plot our rail or train or transport routes and so on. That is the importance of this 3D terrain mapping. Okay, I will stop sharing my screen so I can plug on the my slide. Okay, so it's just like I said earlier on. I think I'm happy I didn't omit putting this part of the session where I had to show the steps to achieve this 3D terrain mapping. Okay, so we can be able to use this anyways. So at least considering what we faced so far, I believe when we follow these steps, you can still arrive to what I just got. I also share screenshots of the procedures and different ways on how to convert the map to local, how to incorporate the DM into the ground to as a elevation source, and how to properly integrate the GM as a ground surface layer. I think my screen has gone off again this time because I saw when it moved. Okay, so let's not spend more time than this. Okay, so these are the next steps when it comes to advanced analysis, how we can now begin to integrate our watershed boundaries, integrate the land use, land cover data, and of course also integrate the road network um, data, and so on and so forth. Okay, so I believe we'll be able to learn um, how these DMs are downloaded or sourced. I can also understand that at the end of this day, we can be able to say, oh, we can probably project and clip or mosaic and also extract by map, trying to improve the output quality of our study area. And I believe we can be able to convert now. Anyways, I know the time didn't permit us to do the whole of this, but we'll be able to convert from the 2D to 3D, and of course also see how we can adjust our exaggeration highlights. Okay, so I think that's basically is all we have for now. So like I said again, I know our time didn't permit for the whole of this, and then we were having issues with our connectivity here, but it's important. You can see, check out the steps are included there on the slide for us to be able to have a brighter visuals on this. Thank you. I think this time I would appreciate if I can get to know any questions, if time may permit. Miss Idris.
Thank you so much for that powerful session, extensively explaining how we can have our 2D images visualized realistically. I don't know, some persons have logged off, but for those still on the call, do we have questions for Mr. Emmanuel? I think we can take one or two.
Yes. Please.
Hi, thanks. Thanks, Emmanuel. Well done for your presentation. It's good to see the case use cases for 3D mapping and 5D mapping, as the case may be, for usability. So when you think about our key urban areas in Nigeria or elsewhere, a lot of people, I remember a few years ago, there was this flooding that happened in Trademore Estate on Airport Road, and that caused a lot of damages and losses. Are there, what do you know about Abuja Municipal, or even just all the area councils, for example, their departments for planning, urban planning? Because even the other day, there was someone posting on social media somewhere around Katampi, I can't remember where exactly, but they said the property developers were actually, no, they were dragging the minister of the FCT, and the property developers were literally in the middle of a floodplain. They were reinforcing concrete and all that. Do we have information, or what do you know about, how these urban planners or our FCT, GIS teams, are they using this kind of technology? And if not, what do you think about how to make it mandatory or part of the need when people are having site planning done? Like, how do we make sure this is enforced beyond just, again, within professional circles, we have these conversations? Over.
Okay, thanks, Mr. Joshua, for that question. Well, I have a sector I deal with, but I can see through a little light on that because I've been privileged to as well work with the Federal Ministry of Housing and Urban Development. I know you talked about FCTA, so, and I believe those in charge of that is AGIS, that's Abuja GIS Geographic Information System. Okay. I believe FCTA as well equally have their urban planning departments, and of course, they likely work have GIS teams to manage development and mitigate risks and all those kind of things. But I said I'll use in line with where I have my little experience from, and that is the Federal Ministry of Housing and Urban Development, to be precise, the lands department. So talking about land now, people having conflicts. There's also called um, land disputes resolution. Those kind of things. We've been able to grow to an extent where we have integrated GIS, and yes, I already mentioned about FCTA, and here we have in the ministry, we're able to integrate GIS and seeing how we can, of course, reach out to other branches out there in the states under the federals, how they can integrate GIS into their land registry. This can be able to mitigate some of these issues arising when it comes to land. People, okay, like disturbing or bordering the fights, not having issues or laying complaints to the minister that they have grabbed the land or some kind of crisis has arisen. And not just that, today, I understand, some other political things that could come up, which has no business with me in this session. But the thing is this: as long as um, they are willing to make proper use of this GIS team or departments, this, of course, issues like this could be easily mitigated. And like what to talk about today now, this 3D GIS. Now imagine if they have embraced this and understand clearly how applicable it is. Issues like this could be easily sorted out. We're able to map out where belongs to where, or what belongs to what, and what land use could be used for a particular reason. So just like I said, sir, I believe there are departments who are in charge of that under FCTA. And then, like I mentioned here, this is what they have been doing in the ministry, trying to see how we can get to that phase where all these kind of issues could be resolved or easily mitigated. Thank you, Mr. Joshua. I don't know if I really answered the whole thing you wanted, but that is the little line I have for that.
Thanks for that feedback. I think organizations like SDSSN are positioned to act as pressure groups. I know we're not in shortage of agencies that should be responsible for these things, and they don't do anything about it. So perhaps those of us who have foothold in those bigger organizations that influence policy, use forums such as SDSSN to act as a vehicle towards they're kept on their toes. Thank you.
Yeah, thank you for that contribution as well, Mr. Joshua. I don't know if there's any other question. Okay, so because of the time, I really want to appreciate you. I will really appreciate the participants, and I hope that you found this session helpful and inspiring. I also want to appreciate SDSS and once more for this opportunity. I know time didn't permit for the whole of this, but we hope that in our next session we can be able to dive in deep and see how we can also advance on our analysis. All right, thanks once again, and thanks to the Spatial and Data Science Society of Nigeria. Over to you, Rekia.
Okay, thank you, Mr. Emmanuel. Thank you so much for making out time to educate us on the importance and relevance of 3D mapping. I'm sure we all have take-home knowledge from this training session, although we've taken an extra 30 minutes, almost 30 minutes of our time, but I know that the take-home is, I think it compensates for the extra time that we have spent. So thank you for making our time to educate us, and to our amazing participants and attendees today. Thank you for sticking with us, and let's keep making impacts using spatial and data science. And like I said earlier on the call, you can register with SDSSN and contribute your quota to the mission, to achieving the mission and vision of SDSSN. Let's apply let's apply spatial and data science knowledge to solving problems and issues in Abuja, like Mr. Emmanuel said, not just Abuja, in Nigeria, Africa, and the world. So thank you. You could visit our website, sdssn.org, for more information. And these recordings will be shared via emails via emails. And thank you everyone for joining once again. Do have a good evening and an amazing weekend. Bye for now.
Thank you. Bye.